Good day students, let's start the class for day 5. So in day 5 we are going to start superposition of waves. Okay, superposition basically means is there are two waves produced by two different sources and the two waves are meeting at one point. So because of that reason the meeting point will have simple harmonic motion because of the two waves. So because there are two waves which are interfering, its simple harmonic motion will be different than the sources, the two sources. Okay, let's see in superposition what is happening. So if suppose we say here is a source 1, it is producing this kind of a wave, and there is another source here which is producing this wave, and both these waves are meeting at a particular point. Okay, let's say its position from here is some x2 and its position from here is x1. For the time being we are assuming both the sources have same angular frequency omega. Okay, same angular frequency omega. So if I write the simple harmonic motion of this particular point P, then we can say that the simple harmonic motion of P will be equal to the sum of two simple harmonic motions, one given by this source S1 and another one is given by this source S2. Okay, but before that we will be writing what is Y1 and Y2. Y1 is simple harmonic motion because of the first source. So that Y1 we can write as something like A1 sine maybe K. If suppose K we are taking same, we can write K, or if you want to take it different, let it be different. K1 x1 minus omega t plus phi 1. Y2 we can take as A2 sine K2 x2 minus omega t plus phi 2. Okay. Now if you want to know that what is the phase difference between the two, phase difference will be the difference of these two. Okay. Omega t is same, so that will get cancelled. So phase difference here between the two will come as K2 x2 minus K1 x1 plus phi 2 minus phi 1. Now this phi 2 minus phi 1 is initial phase difference, whereas this is the phase difference because of the paths travelled by the two waves. x1 and x2 are what? The positions of that point. So this is the paths travelled by two waves. So this is because of the path difference and this is initial phase difference. Now this total we are writing as delta phi. Okay. Now to calculate this y1 plus y2, we are rearranging them. So how we are writing it? Let's see then. This first one y1 I am writing as a1 sine omega t plus omega t only you write, don't write anything else. And y2 I am writing as a2 sine omega t plus delta phi. Now what is the phase difference between them? Delta phi. What is delta phi? This is delta phi. Okay, so I adjusted this delta phi over here. Why it's like this? So that we can solve it easily. Otherwise if you are using it, it will be complicated. So let's see what's coming after adding this. So y equal to y1 plus y2 we have, or yp equal to y1 plus y2. y1 value a1 sine omega t. This I am going to open, this sine of a plus b. So it will come as a2 sine omega t cos delta phi plus cos omega t sine delta phi. Okay, now sine omega t among this we will take common. What is going to come? If I take sine omega t common here, it will be a1 plus a2 cos delta phi. Now what is remaining? a2 cos omega t sine phi. Cos omega t a2 sine phi. This is yp. Now this also we would like to convert in the same form like this. Okay, so what we can do over here, this a1 plus a2 cos phi or delta phi we are assuming as A cos theta, and this A2 sin phi we are assuming as A sin theta. Okay, we assumed it. Now we are going to square it and find the value of A. Okay, square this one, so it comes A square sin square theta plus A square cos square theta. So see what's coming. A square cos square theta plus A square sin square theta equal to square of this, so A1 square plus A2 square cos square delta phi plus 2A1 A2 cos delta phi, and plus square of this one also, so plus A2 square sin square delta phi. Okay, now A square cos square theta plus A square sin square theta. A square taken common, cos square plus sin square theta is 1. So what we are going to get over here? A square. So A square is equal to here A1 square plus 2A1 A2 cos delta phi plus A2 square, I am taking common here, cos square delta phi plus sin square delta phi, that means 1. Okay, so this is 1. What we are getting? A1 square plus A2 square plus 2A1 A2 cos phi. That's the resultant amplitude. Or A equal to A1 square plus A2 square plus 2A1 A2 cos delta phi squared. This is the resultant amplitude, and which is very similar to the resultant of a parallelogram law. Okay, so from this one we can use this also in the same way as we did the vector law or vectors addition law, parallelogram law. We can do the same way. We say that this is A, this is A1, this is A2, and this is the resultant. Okay, angle between them is delta phi. So if we want to know this angle, which we have said that this is theta. So how to find this theta? Again, we can use parallelogram law. Tan theta will be equal to A2 sin phi by A1 plus A2 cos phi. This is delta phi. Okay. This is exactly same as our parallelogram law is. From where this came? This also we did right now. Little while ago we did something like this. We written A1 plus A2 cos delta phi as A cos theta and A2 sin phi as sin delta phi as A sin theta. Okay, this by this is tan theta. The tan theta will be equal to A2 sin delta phi by A1 plus A2 cos delta phi is here. Okay, so it's very similar to what we have studied in vectors. So we can remember it easily. So whenever two waves are reaching at a point, their amplitudes are A1 and A2, the resultant amplitude will be calculated like this. Okay. Now when we are saying that the amplitude is changing, and since wave carry energy, okay, so energy at that meeting point also will change. How it will change, that also we can see. Now we already know intensity of a wave is half rho omega square a square into velocity. Now in this one, this rho is a density, mass density, so it is constant. Omega depends on the source, it's also constant, and speed, because it's omega by k, that is also constant in a medium. So I is actually what? Proportional to a square. Okay, so if two sources are there, their amplitudes are A1 and A2. We can say their intensities are I1, which is proportional to A1 square. Same way, intensity of other wave is I2, which is proportional to A2 square. Okay, now we already know that the resultant amplitude is A square equal to A1 square plus A2 square plus 2 A1 A2 cos of delta phi. This expression we can change in terms of intensity also. Here I can write this as, suppose this I is equal to Ka square, that is a constant one. This also will become I1 equal to Ka1 square. This will become I2 equal to Ka2 square. So in place of a square, if I am going to write this as I by k, this is I1 by k, this is I2 by k, plus 2 I1 by k square root, I2 by k square root, and cos of delta. This k here, and this k also cancelled. So what we are getting? I equal to I1 plus I2 plus 2 root over I1 I2 cos phi. Okay, this will be the resultant intensity at that meeting point. Alright, now when can this intensity be maximum? This intensity is depending on what factor? Intensity I1 depends on the source, so you can't change it. This is also depends on the source, but here one factor is there which will change is delta phi. How it can be changed? Because it's possible that the waves are meeting at different points. Okay, you can change the position of meeting points. So once you are changing the position of meeting point, your delta phi also changes. So where this intensity can be maximum? So for I maximum, this delta phi should be such that this cos delta phi become maximum. That means this delta phi should be what? 0. Delta phi should be 0. So if it is 0, then I max will be how much? It will be I1 plus I2 plus 2 root over I1 I2. Okay, that means root over I1 plus root over I2 whole square. Okay, I maximum is root over I1 plus root over I2 whole square. Okay, now when can it be minimum? When this cos delta phi is minimum. What is minimum value of cos? -1. So that means when this is -1, it will be minimum. So for I minimum, delta phi should be pi, 180 degrees. What will be I minimum value then? It will be I1 plus I2 plus 2 root over I1 I2 cos phi. Cos phi is -1. So what we are going to get? I minimum will be equal to root over I1 minus root over I2 whole square. Okay, it is root over I1 minus root over I2 whole square. So this is minimum value of intensity at any point, and this is maximum value of intensity at any point. Okay. So if suppose some question is asked from us, it says amplitude of the two sources. Amplitude of the two sources is given in a ratio like 3/5. Okay. So what is the ratio of maximum to minimum intensity produced by the waves meeting at any point? Okay. A1 by A2 is given. From here we have to find I max by I minimum. So A1 by A2 we can write as A1 square by A2 square equal to 9/25. Okay, we can do like that. Now A1 square by A2 square actually means is I1 by I2 is 9/25. How can we say? Because we saw that I is directly proportional to A square. So I1 by I2 is 9/25. Now what I want? I want root over I, because this I maximum is what? Root over I1 plus root over I2 whole square. And minimum is root over I1 minus root over I2 whole square. So from here, first again I will go to root over I1 by root over I2. What is that? It's 3/5 again. Then I will use componendo dividendo, that is root over I1 plus root over I2. That means 3 plus 5 by root over I1 minus root over I2. That means 3 minus 5. Okay, so root over I1 plus root over I2 by root over I1 minus root over I2 is 8 by minus 2. Now what I will do? Square that. So this becomes 64 and this becomes 4. Our answer is 16:1. So our answer here is 16/1. Okay, this is the way to calculate it. So that's all for now. that is superposition of waves.